So yesterday we talked about solving systems of equations in two variables as kind of a review. Today we're going to talk about solving systems of equations in three variables. So instead of two variables, we'll have three. Instead of two equations, we'll have three as well. So let's just jump right in. Just talking about linear equations in three variables first. A linear equation in three variables, x, y, and z, is an equation of the form ax plus by plus cz equals d, where a, b, and c are not all zero. The following is an example of a system of three linear equations in three variables. Equation 1 is 3x plus 4y minus 8z equals negative 3. Equation 2 is x plus y plus 5z equals negative 12. And equation 3 is 4x minus 2y plus z equals 10. Now yesterday, when we solved our system in two variables, our answer was an ordered pair, x comma y. It was a coordinate on the plane. A solution of such a system as today is what we call an ordered triple, x comma y comma z, whose coordinates make each equation true. So we have to solve for all three variables in the system. The graph of a linear equation in three variables is a plane in three-dimensional space. The graphs of three such equations that form a system are three planes whose intersection determines the number of solutions of the system, as shown in the diagrams not below but on the next slide. So let's move on to the next slide. This is just kind of a visual of what's going on with the solutions of our systems of linear equations in three variables. If we have exactly one solution, that means the planes intersect at a single point, our x comma y comma z, which is the solution of the system. So that'd be that point right there in the middle of the graph. If we have infinitely many solutions, the planes intersect in a line. Every point on the line is a solution of the system. The planes could also be the same plane. Every point in the plane is a solution of the system. So here we're looking at that line right there. That would be that'd be my line of the solution of those three planes in that case. If we have no solution, that means there are no points in common with all three planes. In this first example, each plane shares points with another plane, but they don't all three share points at the same time. Kind of the same thing with the second one. And then this third one right here, those planes don't touch at all, so they don't have any intersecting points or lines, so that would also be no solution. So that's just kind of a visual of what's going on whenever we are solving these systems. So let's write down these steps of solving a three-variable system. Step 1, we want to rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method. So yesterday we used graphing, substitution, and elimination. Today we're only going to use substitution or elimination. So we want to break our three variable system down into a two variable system. That's step 1. Step 2, we need to solve the new linear system for both of its variables. So we're breaking it down into a system of two variables. Now we need to solve for those two variables. Just like we did yesterday, solving for one of the variables, plug back in, get the other variable. And then step 3, once we get those two variables, we can substitute those values from step 2 into one of the original equations and solve for the third and remaining variable. We have to have our x value, our y value, and our z value. Also, just like yesterday, if we ever attain a false equation, such as 0 equals 1, after my variables cancel each other out, in any of the steps, then the system has no solution. When we do not obtain a false equation, but obtain an identity, such as 0 equals 0, the system has infinitely many solutions. So false statement, means I get no solution. True statement means I get infinitely many solutions. So knowing all that, let's jump into some examples. So my first one here, it's going to have one solution. This example is from the book, so I already know it's going to have one solution. But let's see how we solve it, how we approach it. So I have 4x plus 2y plus 3z equals 12. 2x minus 3y plus 5z equals negative 7. 6x minus y plus 4z equals negative 3. So once again, looking back at my steps, I want to rewrite my 3-variable system as a 2-variable system. And I need to either use substitution or elimination. Now in this case, I probably can't use substitution because in all three of my equations, I don't have any variables isolated on one side of the equation. So I'm going to probably be using elimination at this point. So I've got to look at all of my columns of variables. My x column, my y column, and my z column. I can eliminate any of my variables, but sometimes it's a little easier to eliminate one variable over the other two. In this case, I'm going to eliminate y because one of my y's has a coefficient of 1. That's going to help me out. I'm going to only have to multiply that equation by something. So I'm looking at my first equation and my third equation. If you remember from yesterday, in order to be able to eliminate a variable, I need the same number, opposite sign, so I can just add my equations and they eliminate. So I said I want to eliminate my y. So my first equation has a 2 in front of it. My third equation has a negative 1. So I'm going to multiply my third equation by positive 2. So over here, I'm going to write my first equation. Just rewrite it. 4x plus 2y plus 3z equals 12. And then I'm going to rewrite my new equation after I multiply the third equation by 2 right below it. So 2 times 6x gives me 12x. 2 times negative y gives me negative 2y. 2 times 4z gives me 8z. And 2 times negative 3 gives me negative 6. Now in my y column, I have the same numbers, opposite signs. So I can just add my equations and my y's will eliminate. 4x plus 12x gives me 16x. 3z plus 8z gives me 11z. And 12 plus negative 6 gives me 6. This is my first equation of my 2-variable system that I got. So I now need another equation. So now I'm going to look at my second equation with my third equation and eliminate y once again. That way I have 2 equations with the variables x and z. So I need to multiply my bottom equation by something again. Now I need to look at my second equation. My second equation has negative 3 in front of the y variable. To get a positive 3 in front of the y variable in my third equation, I need to multiply the third equation by negative 3. So I get, I'm just going to rewrite my second equation, 2x minus 3y plus 5z equals negative 7. Multiplying my bottom equation by negative 3, I get negative 18x plus 3y minus 12z equals positive 9. Adding these two equations, (2x plus negative 18x gives me negative 16x. My y's are eliminated. 5z plus negative 12z gives me negative 7z, and negative 7 plus 9 gives me positive 2. I now have a system of equations in two variables. So that I am now done with the end of step 1. I realize this takes a long time. That's okay though, we got to get through it. So I'm going to erase some of my work to give me some more room. I'm going to leave that system in two variables there. So now I'm solving this system in two variables for both x and for z. So I'm just treating it like I did yesterday. I'm going to use elimination here because in my x column I already have same numbers, opposite signs. So if I add these right off the bat, my x's get eliminated. 11z plus negative 7z gives me 4z, and 6 plus 2 gives me 8. Now I can find my z variable. Divide both sides by 4. I now know z equals 2. That's one of the numbers on my ordered triple. Make sure you have your numbers in the correct order. X comes first, y comes second, z comes third. So there's my third variable of my ordered triple. Now I need to plug this z equals 2 into one of these two equations right here to find x. I'm going to use the second one, negative 16x minus 7 times 2 equals 2. Negative 7 times 2 gives me negative 14. Add 14 to both sides. I get negative 16x equals 16. Dividing both sides by negative 16, I get x equals negative 1. So there's another one of my variables within my ordered triple. So I now know x equals negative 1, z equals 2. Now I can plug both of these values into one of my original equations over here to get my y variable. So once again, I'm going to erase to give me some more room. So I can just pick any of these three equations over here to plug into. I'm just going to use the top one. 4 times x is negative 1 plus 2y plus 3 times 2, which is z, equals 12. Now I'm just working it down, solving for y. 4 times negative 1 is negative 4. 3 times 2 is 6. Combining my like terms, I get 2y plus 2 equals 12. Subtract 2 from both sides. 2y equals 10. Divide both sides by 2. Y equals 5. There's my y value. So I now know my ordered triple. That's a solution to this system of equations in three variables. Is the ordered triple negative 1, 5, 2. Yesterday we checked our solution. Today it's already a lot of work as it is, so I'm not going to make you check your solution today on these. So I would just end there because I solved my system and found my ordered triple. So let's move on and do another example. I have x minus 2y plus z equals negative 11. 3x plus 2y minus z equals 7. And negative x plus 2y plus 4z equals negative 9. Once again, the very first step I need to do is rewrite my system in three equations as my system in two, in 3 variables as a system in 2 variables. So I think y is going to be the easiest variable to eliminate here in this case as well, because they're all 2's. And one of them already has an opposite sign. So I'm going to just add my first and second equation right off the bat. Because in my y column, I already have same number, opposite signs. So x plus 3x gives me 4x. Y's get eliminated. We get lucky in this case because my z's also get eliminated. Negative 11 plus 7 gives me negative 4. So right off the bat, I can go ahead and find my x value. Solving for x, I get x equals negative 1. So I've already found my x value right off the bat. Now I'm going to look at my second equation, or my first equation. Hold on one second, having technical difficulties here. Now I'm going to look at my first equation with my third equation. X minus 2y plus z equals negative 11. Negative x plus 2y plus 4z equals negative 9. Once again, in my y columns, I already have same number, opposite signs, so they get eliminated. In this case, my x's also get eliminated. Z plus 4z gives me 5z. Negative 11 plus negative 9 gives me negative 20. Now I can just solve for z. Dividing both sides by 5, I get z equals negative 4. So I've already found x and z right off the bat. Now all that's left to do is to plug into one of my equations and solve for y, since I've found 2 of my 3 variables. So I'm just going to use this top equation, plugging negative 1 in for x, minus 2y, plus z would give me minus 4, equals negative 11. Combining my like terms, I get negative 2y minus 5 equals negative 11. Add 5 to both sides. Negative 2y equals negative 6. Solving for y, I get y equals 3. So my answer here would be negative 1, comma 3, comma negative 4. That would be my order triple for example 2. So those are 2 examples where we have just one solution. Let's look at an example where we get no solution. And let's act like we don't know it's no solution. Let's try to solve it like we did the other 2. Let's try to get a system in 2 variables. So once again, I'm going to try to eliminate my y variable. So I'm going to look at my first and second equation right there. So I need to multiply my top equation by negative 5 to be able to get the same number, opposite sign in my y column. So multiplying that through, I get negative 5x minus 5y minus 5z equals negative 10. Now I'm just going to bring my second equation over. 5x plus 5y plus 5z equals 3. Now that I have same number, opposite sign in my y column, I'm going to add my 2 equations. But let's see what happens here. My x's get eliminated, my y's get eliminated, my z's get eliminated. Negative 10 plus 3 gives me negative 7 over here. if everything on the left-hand side eliminates, that just leaves me with 0. Now, 0 obviously does not equal -7. We would say that's a false statement. So if you remember from the few slides before, if I'm left with a false statement, my answer is just no solution. So in this case, I would not have a solution for this system of equations in 3 variables. So if your variables cancel each other completely out, you're left with a false statement. Your answer is no solution. Let's look at the next example. Many solutions. Once again, let's treat it like we did the others. Try to get an actual answer, and we'll see what happens. In this case, I'm going to eliminate my z variables to get it into the 2-variable system, because I already have same number, opposite signs. So I'm going to take my first 2 equations, x minus y plus z equals -3, x minus y minus z equals -3. I'm going to add these equations because my z column already has same number, opposite signs, so they eliminate. X plus x gives me 2x. Negative y plus negative y gives me -2y. -3 plus -3 gives me -6. Now I'm going to do the same thing with my second and third equation because they also have same number, opposite signs in the z column. X minus y minus z equals -3. 5x minus 5y plus z equals -15. Adding these equations right off the bat, my z's eliminate. X plus 5x gives me 6x. Negative y minus 5y gives me -6y. -3 plus -15 gives me -18. So I've now converted my system in 3 variables to a system in 2 variables. 2x minus 2y equals -6. 6x minus 6y equals -18. Now I'm going to try to solve for x and for y. Let's try to eliminate my x value, or my x column. So I need to multiply this top equation by -3. So I can get same number, opposite signs in front of my x. That'll give me -6x plus 6y equals 18. Now I'm adding these 2 equations. Since my x has same number, opposite signs. X is eliminated. My y's also get eliminated, so I'm left with 0. -18 plus 18 also gives me 0. Now 0 does equal 0. This is a true statement. This is what we would call an identity. So once again, from the previous slides, if I have an identity or a true statement, my answer is infinitely many solutions. So once again, I was left with a true statement, so I got infinitely many solutions. False statement is no solution. So I hope this all made sense. We do have a worksheet. I'm going to do 2 problems from the worksheet. So you need to make sure you pay attention, and you probably write this down. You do need to have this work shown on your worksheet, even though I'm doing it for you. So this is number 2 on the worksheet. Z equals x minus 1. 3x equals 12. 6x minus 3y minus 4z equals 3. So right off the bat, looking at my second equation, I can just go ahead and solve for x by dividing by 3. So I can just get x equals 4. Now it's pretty easy. Now I can easily find my z value by just plugging in x. Z equals 4 minus 1, so z equals 3. I'm already over halfway done. This one's pretty easy. Now I can just plug x and z into this bottom equation, this third equation. 6 times 4 minus 3y minus 4 times 3 equals 3. 6 times 4 is 24. Negative 4 times 3 is negative 12. Combining my like terms, I get negative 3y plus 12 equals 3. Subtracting 12 from both sides, I'm going to move my order triple up. I get negative 3y equals negative 9. Dividing both sides by negative 3, I get y equals 3. So my order triple on number 2 on the assignment is 4, 3, 3. Just wanted to show y'all that one because it was kind of easy and I didn't want y'all to overthink it. I'm going to do one more with you from the assignment. This is number 3. 5x minus y equals 19. 4x plus y minus 5z equals negative 3. And y equals 3x plus 3z minus 23. Now all the examples from the notes, we did elimination to solve them. In this case, I can do substitution because one of my variables in my equation is isolated on one side of the equation. I know y equals 3x plus 3z minus 23. So in both of these first and second equations, I can replace y with the expression 3x plus 3z minus 23. So that's what I'm going to do right here. 5x minus replacing my expression, or y with my expression, make sure you distribute this negative all the way through. Get 5x minus 3x minus 3z plus 23 equals 19. Combining like terms, 2x minus 3z plus 23 equals 19. And then subtracting 23 from both sides, I get 2x minus 3z equals negative 4. So there's one equation for my now system of two equations, or system of equations in two variables. Now I need to plug my expression into my second equation. So I get 4x plus 3x plus 3z minus 23 minus 5z equals negative 3. I just replaced y right here with this expression, 3x plus 3z minus 23. So I have a pair of like terms here. which gives me 7x. I've got a pair of like terms here, which gives me negative 2z minus 23 equals negative 3. Add 23 to both sides. I now have a second equation, 7x minus 2z equals 20. I now have a system of equations in two variables. I'm going to go ahead and erase to give me some more room. X minus 3z equals negative 4. 7x minus 2z equals 20. So now I need to solve this system over here to the right. I need to solve it for both x and z. So I'm going to use elimination now. I'm going to try to eliminate my z variables. So I'm going to multiply the top equation by 2. I'm going to multiply the bottom equation by negative 3. So I get 4x minus 6z equals negative 8. Negative 21x plus 6z equals negative 60. And once again, I did this so I could get same number, opposite signs in my z column. 4x plus negative 21x gives me negative 17x. Z's cancel. Negative 8 plus negative 60 gives me negative 68. Dividing both sides by negative 17, I get x equals positive 4. So once again, I know this is a lot of work because I've only found one of my variables now. It gets a little shorter as you go along. It's just the first step that usually takes the longest. So now I know that x equals 4. Now I'm going to plug in x equals 4 to one of these two equations right here. I'm going to use the top one because it's dealing with smaller numbers. So 4 times 4 minus 6z equals negative 8. 16 minus 6z equals negative 8. Subtract 16 from both sides. Negative 6z equals negative 24. So that makes z equal to positive 4. So now I found two variables. I know x is 4 and z is 4. So I'm going to go ahead and put those into my triple. X is 4. I don't know y yet. Z is 4. Now I can just plug these in. I'm going to plug them in to this third equation because it's already solved for y. So y equals 3 times 4 plus 3 times 4 minus 23. 3 times 4 gives me 12. 3 times 4 is 12 minus 23. 12 plus 12 is 24 minus 23. So it makes y equal to 1. So I know number 3, my order triple is 4, 1, 4. So that's how you would solve a system of linear equations in 3 variables using substitution. So now you know how to do substitution and elimination. This assignment that's posted on Canvas will be due on Thursday, October 15th. That's this Thursday on Canvas. I'm trying to do this so you guys don't have a whole lot of homework over fall break. I'm trying to let you do your work, and then get a little break over fall break. So this assignment will be due Thursday, 10:15 on Canvas. Y'all have a good evening.